Hello, I am Pooja Junjunwala. I welcome you all for today's webinar session. This is second in series of our ongoing educational webinar series. Last week we had webinar on pneumatics. This week
Pooja,
I'm going to.
this is another screen actually.
Pooja ma'am, I think you are sharing the wrong screen.
Okay, sorry.
Yeah, thank you.
Is my correct screen visible now?
So we can see the board screen now.
Okay, just a second.
Yes.
Is the PPT file visible now?
Yeah, now I can see the topics.
Yeah, okay. Thank you. Yeah. So today's webinar is on hydraulics, and in the next week, this week itself, we have another webinar on hydraulics, which will be advanced hydraulics. There we will be covering topics related to component modeling for pump proportional valves. Then we will see in the next webinar how different types of actuator components and impacts of load on them. Then mobile hydraulics, then how you can optimize the system design using manufacturer catalogs, how you can do 3D manifold block creation in Automation Studio, and there will be some demo files. Next week, we will have two webinars on electrical and PLC. In today's webinar, we are going to see how you can design your hydraulic circuit in Automation Studio, how you can analyze your hydraulic circuit. Then we will see how you can do troubleshoot, how can you troubleshoot your circuit in Automation Studio. Then we will go through some illustrated library components which are very useful for training. Then we will also see some of the technical training materials available in Automation Studio, and then there will be some demo files. At the end, there will be a question answers session. While during the webinar, if you have any questions, please post it in the question section. My colleagues will answer you, and if required, at the end, I will answer some of your questions. So before beginning with the how you can design your circuit in Automation Studio, let's go through a quick corporate presentation. So about us. So FAMIC Technology was founded in 1986, and it's a ISO 9001 2015 certified company, and we have a team of 130 engineer and software specialists. We have our headquarters in Montreal, Canada, and our branches are in Europe, it's in Germany, and in India, it's in Pune. We lead the industry by designing world-class trade-oriented tools in the fields of fluid power, electrical engineering, industrial automation, and custom software development. We have in-house expertise in the area of software development, engineering, and industrial automation. In software development, we have team for software engineering, database design, network support, MMA, object-oriented and web-based applications, real-time systems. In engineering, we have team for CAD CAE system, pneumatic system, hydraulic, mathematical modeling, electrical automation, instrumentation, training, and industrial automation, PLC, SCADA, HMI, electrical controls, process simulation, system maintenance. There are we produce 4 products: Automation Studio Professional Edition, which is used to create, analyze, troubleshoot, and validate multi-technology circuit. Today's webinar is for educational edition of Automation Studio, which is widely used to train future technicians and engineers on hydraulic, pneumatic, electrical, and PLC systems through simulations. There are 2 other tools, which is Automation Studio Live Manifold. Now we also have the option of Live Manifold integrated to the Automation Studio, which we will see in the next webinar session. And the 4th tool is End-on Studio, which is a tool used for Industry 4.0, which provides you complete solution to optimize your production. Our solution is sold in more than 120 countries. Our objective is to have a long-term relationship with our clients, to give them effective support by phone, email, or online. We also want to provide dedicated representative for each account. We do provide support material in terms of training videos, demonstration files, quick start guides, etc. So these are some milestones for Automation Studio. After the foundation of the company in 1986, New SIM and Hydro SIM DOS-based software were released in 1988 and 89 respectively. In 1996, Automation Studio's window-based solution was launched, and since then we have kept on evaluating our software based on the demand and the feedback from our clients. And in 2022, Automation Studio 7.1 version was launched, which includes web catalog access. Then we also included document display standards for training and technical documentation, some didactic libraries, ladder diagram for Mitsubishi, and faster simulation for large projects. Automation Studio is a it can be used for the multi-technology and programs. It fits programs like mechatronics, industrial maintenance, aviation, diesel, agriculture, electrical, renewable, electromechanical, mechanical engineering, marine technology, automotive. It is a multi-user collaboration sharing tool which can be used for simulation, animation, machine documentation, and trade-oriented system design for multiple technologies as we see here. What are the key benefits of Automation Studio? For students, it helps them to validate theory studies in class. It also helps them to illustrate system behavior dynamically in full color. It reinforces the understanding of systems interactions and also allows to virtually test all types of system. For teachers, it helps them to demonstrate system interactions. It also helps them to enhance teaching and learning by working on virtual system. It easily integrates into the course content and can be easily handled by both teachers and students. For school, it eliminates the need to purchase single technology software as this software fits multiple programs. It can be used in conjunction with other departments as it is a multi-collaboration sharing tool. It limits the purchase of expensive and often inaccessible hardware. It also trains students on a leading base ACE tool commonly used in industry. It also allows you to give remote access. You can provide access to students of Automation Studio from school or from home. You can also create priorities for teachers and students. As you can see here, you can manage the license. You can create different user accounts. For example, in this image, the account is for students from home, and here you can schedule the access like between this time to this time, student can access the tool in the home, and on which day this tool is accessible to them. Like that, you can provide the schedule, you can create different user accounts, you can put the password for that so that other person is not using it. So like that, different options are available for remote access to. This tool is available in 11 languages and is sold in more than 120 countries. It is used in high school, career center, colleges, universities, workforce development. Then we have, as we mentioned, then we do provide technical training materials. So in Automation Studio, what we have done, we have made the examples of figures shown in these 3 books. We have created those figures examples as a schematic in Automation Studio and have provided that to our user, and they can directly do the simulation. They can analyze the different concepts of hydraulics, electrohydraulic, and it will help them to understand the concept easily and to tease the concept easily. We will see in details when I will give the demonstration. Then there are some interactive exercises in the form of Teachware, and where it will be an automated interactive exercises where you can ask the students to do the answers as per the behavior of the circuits. You can customize it as per your requirement, and you can create your own as well. Then you can also create a digital twin of your own equipment. For example, if you have a hardware training tool, you can create a digital twin of the same in the Automation Studio, and then you can change the properties or create faults for troubleshooting in the digital twin of your hardware circuit, and it also is transition from theory to practice. Then there are some illustrated libraries available. We will see for the hydraulics in today's webinar. Now, what is the benefit of Automation Studio Educational Edition? If you are using only hardware, then if you have 3 hydraulic and electrohydraulic trainers, so only 2 students per unit can work at a time. But if you have 2 hydraulic and electrohydraulic trainer set, then if there will be 20 users of Automation Studio with all modules, and they can do the test virtually. They can troubleshoot, they can validate their circuits prior to the actual hands-on experimentation. They will have access of hundreds of components, which allows them to create many more circuits. It also introduces students to circuit design software. It also make them familiar with ISO symbols, which will help them with blueprint reading skills, and they can also change properties of components to illustrate different scenarios. So you can see that this is a more expensive option and it's a less expensive option. Then we have manufacturer catalogs available for many of the leading manufacturers of hydraulics, pneumatics, and electrotechnicals. By manufacturer catalogs, what we do, we create a digital twin, you can say, or we create a virtual model of a hardware of a valve or something produced by the manufacturer. As per the specification given by the manufacturer, we model the component, and then there will be a virtual test bench where we show like the behavior as mentioned by the manufacturer is there with the component. You can check that and you can confidently use the same. This topic will be covered in detail in the next webinar session. And this is a partial list of some of our industrial clients. In aerospace, we have clients like Airbus, NASA, Agriculture, Sinachai, John Deere, Energy, Hydro-Quebec, Orano, Forest, John Deere, Cubeta, Construction, Caterpillar, Hitachi, Defense, Larsen Tubro, JCB Defense, Metallurgy, China Steel, US Steel, Mining, Epiro, Comesso, Offshore, Cameron, Elnusa, Transport, Honda, Hasco Rail, System Integrators, RB High-Tech, Handling, Skyjack, Terex. So now we can proceed with the topic of today's webinar session. If you will open the Automation Studio, this will be the user interface. In the left, we have Library Explorer, and you can see there will be different libraries of the technologies available here. If you click on a particular technology, hydraulic, you will see the most commonly used components available here. And if you expand the trees, then the components are available in terms of the different categories of the components. If you click on the pumps and amplifiers, then you will find different types of pumps and amplifiers. So there are like thousands of the components available for different technologies in Automation Studio. In the right, we have Project Explorer, through which you can manage the your projects. On the top, we have a ribbon bar where you will have different tabs which will be used for your system design, analysis, and simulations. And this is what we call editor, where you can create your circuit. So let's start with how you can create your hydraulic circuit. So let's say I'm creating a very basic hydraulic circuit. So I will need a unidirectional pump with shaft. I will just drag and drop. You can take multiple components at once from the library and drag and drop into the editor. Okay, so as you can see here, the components visible here, there is gray section and then blue and gray sections. So the moving part of a component is shown in blue color and the fixed part of a component is shown in gray color. So like that, you can have the visualization of the parts of the components too. Now I will make the connections quickly. Now, so for this pump, I will also need an engine as it's connected with a shaft. So I will, from the drive and transmission element, I will take an engine. Now I will very quickly make the connection. So I will bring the engine close to the shaft of the pump. So the connection has been made. Now I will make the connection of the tank with the pump. Now the pump P port, I will connect with the P port of my directional valve, and the two working ports of the cylinder will be connected to the directional valve. Now I will need another tank. I am just using Control C and connecting it to the tank. And for this relief valve, just a second. So now I will connect the in port of the relief valve with the output port of the pump by double clicking on the hydraulic line. The connection has been made. Another tank, and I will connect it to the tank. So very quickly, I have created an hydraulic circuit in no time. Now, if you want to see the cross-section view of this, you can go to the Views tab. You can enable the cross view highlighting, and you can see the cross-sectional view of the lines. You can change the line type. For example, this is connected to the tank. You can make the line type to the return line. So now you can see different lines have different cross-sectional view animation. I will start the simulation, and you can see here this yellow color, it's representing the activated position of the directional valve. So for the extension, I will activate this position of the spool. So now this is yellow, and these colors are also showing the pressure in that region as we are doing the extension and retraction. During the simulation itself, you can change the value of a relief valve. For example, you can use a slider to change the value of the cracking pressure of the relief valve. You can change the displacement of your pump. You can change the speed of your engine as per your requirement, as well as if any component during the simulation is highlighted in red. So if you click right, you can see the animation of that during the simulation itself. So when the system, you can see how the flow is going through the relief valve. So like that, it will be very useful for the students to understand the concept of how a relief valve works. Now, and there are different tools available in the ribbon tab for the analysis during the simulation. For example, if you want to see what is the linear speed or linear position of your cylinder, then we have different measuring instruments, dynamic measuring instrument. This is component dynamic measuring instrument. So if you click on the cylinder, from here, you can select the property which you want to measure for that cylinder. For example, if you want to see what is the linear speed, you can select that property. Then you can see that value in different unit as per your requirement. You can set the precision as per your requirement. Even you can record that value during the simulations. So if it's a red, it means that value is getting recorded. So now you can see the speed of the cylinder. You can have different multiple measuring instruments on a single component. So if I want, I can add another measuring instrument for the cylinder, and I can also check what is the position of my cylinder. So this way you can use the dynamic measuring component dynamic measuring instrument. Then there is no dynamic measuring instrument. So let's say if you want to see what is the pressure at this point, you can use this no dynamic measuring instrument and you can check the pressure. Similarly, if you want to see what is the pressure difference between these two ports, you can use the differential dynamic measuring instrument. And it will be visible to you. Similarly, these are the tools which can be used for the analysis during the simulations. In the addition phase, you can have other options like plotters. So first is YT plotter. If you click it once, now this YT plotter, you can plot a variable with respect to time. For example, I recorded this value during the simulation. You can drag and drop this measuring instrument here, and you can have the value here. So as you can see, I have adjusted to y-axis, so all my recording is here. You can add different cursors in the plotter to see what is the value at a particular instant. You can have multiple cursors. You can have annotations to depict like which position during which time this value was taken. Then you can also display the measurement points. You can change it. You can display the legend. For example, if there are multiple, you can have multiple properties with respect to time in a single plotter. So let's say I will drag and drop this cylinder and I will have another axis. So now in the legend, you can have multiple variables, and as per your requirement, you can see only results for one variable. Then you can log the values that you have calculated during the simulations, and you can use that data and to compare with the different sets of values and compare the results of the two plotters. You can print the plotter image, you can copy the plotter image. If you copy, you can paste it in your technical publications requirement, or you can paste it on the Automation Studio itself. Then You can also export the measurements, whatever you have, it will be exported in the text file. Then you have multiple options here to change the axis initial maximum value. You can change the curve color as per your requirement, line pattern, width, etc. In the plotter itself, you can also add background image. For example, here it is like background color is black and there is no image. You can add an image as per your requirement. Like that, multiple options are there for you as per your requirement. So again, if I start the simulation, so now I will have the results of the linear speed as well as the length of the linear position of the cylinder. So if I stop the simulation, you can adjust with respect to y-axis. You can have the results in terms of the x-axis or y-axis. So like that, you can use the YT plotter. And then there is y-axis plotter, wherein you can have the plot of one variable with respect to another variable. For example, I want to measure linear speed of the cylinder with respect to the flow through the pump. So now let's say you have added two variables, but you want your flow to be in the x-axis and speed of the cylinder on the y-axis. So you can go here and you can change your x-axis as output flow and it will be changed. And then if you start the simulations and if you vary the flow through the pump, so you can see the effect of that here itself. So like that, you can use the plotters. Then there is another plotter, ZXY plotter, wherein you can have the plot of three variables with respect to each other. So this was about some of the measuring instruments and the plotters available here in the Raven bar. Then in the library itself, there will be different sets of measuring instruments, sensors available, which can also be used for your analysis. Now, let me delete this measuring. Yeah. So now if you want to do troubleshoot of your circuit, for example, if you want to train your students like different scenarios of a hydraulic circuit, so I'll go to the troubleshooting and purposefully I will just activate a failure. I have activated a failure jam piston. Now I start the simulation, and if I try to extend, my cylinder is not getting extended, and the person who is doing the analysis of the circuit doesn't know the reason behind this. So you can use the hydraulic tester. He can just, since I know that the flow is going through the relief valve and everything is fine, so there is no problem till this part of the circuit. So I will use the hydraulic tester here and I'll check. So let's say for our better understanding, this is 50 and the speed is 2000. So there should be 100 flow. So the flow is going through this 100. So no issue here. Now, if I connect here to here, yeah, so I can again see that just a second, the tester is not. Yeah, so there is no problem in my DCV. You can see the flow is going through this. And if I connect it at this part of this, again flow is going through this, but here there is no flow. So I'm sure that the problem or failure is because of something is wrong in this cylinder. So I can use the repair tool. I can click here and I'll select all failures, or you can select one by one. If I click on this and again if I start, I can see that my cylinder is extending. So the cylinder was jammed. I need to remove this. So now it's so like that you can troubleshoot this. Then there could be another type of troubleshooting scenario where it is not forcefully activated, but it's dependent on certain parameters. For example, this failure will occur if the system pressure, it overshoots the maximum pressure limit of this cylinder. So the cylinder will be jammed. So I have activated the failure local activation, which is dependent on the maximum pressure. I'll go to the data tab and here I'll see what is the maximum pressure of my cylinder. It's 450. Let's reduce it, make it 250. In the project properties, here I will activate monitor faulty components, automatic failures, and now I will start the simulation. Now, since you can see that the system pressure is well below 250 bar, my cylinder is getting extended and retracted. Now I will increase the pressure of relief valve. You can see here there is a warning message which is showing that the maximum pressure exceeded on connector A. If I click here, it will take me to the component with the failure. And if I try now to retract, the cylinder is not getting extended. Now, since the maximum pressure was extending, I'll reduce the failure messages. Warning message is gone now, but still my cylinder is not moving. It's jammed. Because it's jammed, now I need to again use the repair tool. I'll use a repair. And now my cylinder is, this failure has gone. So now again I will go to the project properties and I'll deactivate this. Okay. Now you can also introduce the failures in the hydraulic lines itself. So if I go here in the troubleshooting, I'll add a failure. For example, there will be external link through this hydraulic line from the port 1 and it is dependent on like 10 centimeter cube per second per bar. I'll activate this. Now if I start the simulation, let's make it 80. Okay. So if I again see the linear speed of my motor, sorry, cylinder, it will be less than usual. And if I need to find, again, you can also add the measuring the flow through this relief valve. What is the flow? Now you can see here that the cylinder has reached to its retracted position and the flow through this pump is 100 liter per minute, but the flow going through this relief valve is 25.9 liter per minute. It means there is some problem in this section. So because of the external leak that we have added here, the flow through the relief valve is lesser than the flow going through the pump. So like that, there could be, you can create different troubleshooting scenarios with, for your understanding or also for the training. Okay, then as mentioned, there are some illustrated libraries also added in the Automation Studio. So if you click on this orange section, so you can see there are different libraries available here. For example, this is for the cylinder plus load. So different scenarios of load is already created here and it can be directly used in your analysis. Then there is a hydraulic sectional components and sectional component link, how that can be used. I'll just show. So for example, I'll take a cylinder, double acting cylinder. Okay, and I will link it to the cylinder of my hydraulic circuit. Okay, from here I will make the link and you can see the cross-sectional view of the cylinder in this animation. And it is also showing the pressure, like the red color is showing the high pressure, blue color is showing the low pressure region. So like that, it can be used for the understanding of the flow, like how the flow is going through the cylinder inside it. Similarly, you can use the hydraulic sectional components library for the training purpose. So here you can create the complete circuit. Let me just adjust the circuits here. Okay, so this is a tank and from here I'll enable the component ports. So for the tank, this is a source port, this is a return port, then this is my pump. I'll take a unidirectional gear pump. So this is the input output. Then there will be actuator cylinder. I will just take a double acting cylinder. And you can have a directional valve to control the actuation. Okay, so let's say I have taken a solenoid control 4x2 bidirectional valve. Okay, and also I will need a relief valve from the pressure section. Okay, so this is my relief valve. So I'll connect this source port of my reservoir with the input of the pump. Then output of the pump will be connected to the P port of my directional valve. Also, the in port of the relief valve will be connected to the this port, and output of the relief valve. You can also change the orientation of the component as per your requirement. Right now I'm doing it fast, so not changing it. And then this tank port also will be connected to the return of the tank. You can have the multiple tanks or a single tank. And then my B and A port will be connected to the A and B port of my cylinder. So let's say A port. Okay. Now for the activation of directional valve, I will need, just because it's a solenoid valve, I will need a electrical controls. So I will just take a very basic electrical component. I will just take a push button here and make it start. And I'll go to this directional valve. In the variable assignment, I will link it to the start button. Now if I start the simulation, so if I use this start, my cylinder is getting extended, retraction. So the complete animation of the components can also be taught or used for the training using this type of illustrated libraries. Then these are some of the illustrated libraries that are available. Then as mentioned, there are some technical training materials available with Automation Studio. For example, here, this is a section called Technical Books of Hydraulics. If I click here, so here, different chapters of 3 hydraulic book, the world famous 3 books, Introduction to Hydraulics for Industry Professionals, Electro-Hydraulic Components and Addition, and Fluid Power with Application, 7th editions are added in this book schematic catalog. Here, if you go and if you magnify this, you can see the circuit available in a particular chapter example. Similarly, if I open this, I'll just open the PRX. Okay, so this schematic, in the title it is written, it's a hydraulic resistance in series. So you can teach the concept of hydraulic resistance, and the name of the book, author, the figure number, the page number of that book is mentioned here in the title box. And if you start the simulation, so since you can see that the cracking pressure of my this valve is 20 bar, so the pressure is here. This is 30, so 30 plus 20, 50 bar is there. 40, 50 plus 40, 91 bar is there. So like that, you can teach the concept like how the pressure at different ports will be there if the check valves are connected in series. What will be the effect if, for example, if I make it, let's say 0, so it has been reduced by 20 bar, like that. You can teach a different concept. If you add a relief valve here, what will be the effect of that in your pressure? Like that, different scenarios can be created and can be used to teach that concept. Similarly, there is another example for hydraulic resistance in parallel. Okay. Yeah. So here 2 different scenarios are there. In one scenario, 3 different check valves of different cracking pressure is connected in parallel. And here 3 different orifices of different opening diameter is here. If you start the simulation, you can see since the least resistive path is the check valve with cracking pressure of 20 bar. So here the pressure is 20.37 bar. But in this case, there are 3 orifices with different restrictions. So the diameter, the maximum diameter of each of these orifices is 20, but the opening of this one is 1, this is 2, 3. So this is a orifice with most restriction. So if you'll see, the flow going through this orifice is smallest in comparison to the 3 orifices, and most of the flow is going through this 3 mm opening diameter orifice. So that's why the system pressure, the pressure at this point is 191.88 bar, because there is restriction at each point and opening flow can go through each of the orifices. That's why the pressure has built up here. But in this case, this check valve will not open until the pressure is 30 bars. Since at the once the 20 bar pressure was raised, the flow has started going through this shake valve, and that's why the pressure is not getting increased in this section. If I completely open this orifice, for example, you can see since there is no restriction, so the pressure at this point is only 0.75 bar. So like that, different scenarios can be taught using the already presented inbuilt circuits in this technical book section. Then apart from this, there are some teachwares available. As mentioned, these are the interactive exercises. So if I click on this hydraulic, so this will give you different list of activities. For example, there are different interactive exercises available to teach different concepts of physics. Pascal principle, the flow concept, the pressure loss in orifices, the pressure compensation concepts. Then you can also use this inbuilt exercise to teach how you can create a circuit. Then there is exercise based on that, how you can identify the different components of the hydraulics. Then after identification, you can create the circuit. Like that, different types of exercises are available. Then there is exercises based on different components of hydraulics. For example, if pump, you can use these exercises to understand or teach the different types of pumps. Then there are topics for theoretical, then load sense pressure compensated pump, which is explained by design, explained by performances, different pumps parameters, pumps general exercise, like that. So if I open, for example, one exercise for just to give an overview how this exercise works. So if I open this will be an audio visual exercise. Maybe you will not hear the audio during this webinar, but there will be audio there to give you the instruction how you need to proceed for this. So like that, this button will be there, like, are you ready to start or not? So first I will just cross it. So again, I'll just get the message like, do you want to visualize the activity content? Then yes, I want. So I'll just, so here you can see, and on the right side of the page, there is a hydraulic circuit present here, or on the left side, let me close this. Yeah, and on the left side, there are some certain sets of questions available here. You can use these exercises to take the test. Students can put the date here, they can put their name, and at the end, once they are ready with all the answers, they can save it in the form of PDF. So let's start again. So I will reload using this tab. I'll continue. Yeah. So you can see now nothing is there. If I'll start the ready to start, so it is showing me like you need to observe this circuit on the right. Once you have observed, you can validate. Now there is first question, like what will happen when the directional valve D1 is not activated? Since it is not activated, my cylinder is not getting extended. All the flow through this pump is going through this relief valve. Like that, student give the answers. Yeah, then it is asking me to activate this directional valve using this lever. So I need to validate. So I'll activate. So now it's asking whether the cylinder C1 extend when D1 is activated. I can say yes. What is the pressure rate on the pressure gauge P2? So you can write the pressure in form of bar or something. So if I click here, I can write the values here, like 130 bar. Then if I'm ready with my answer, again, I'll proceed. Now, then you can ask for the conclusion, like how a 3/2 normally closed direction valve works and which of the following expression is used. Like that, once you are ready with the answer, you can validate. Now it is asking me whether you want to print your file in the form of PDF or you want to close the project. If I want to print the PDF, I'll print and I'll give the name, for example, hydraulic. I'm not writing my name here, or name Pooja. Okay, and I can save the file in form of like answers webinar. Okay, and then it will be saved, and then that can be used for the the evaluation of your students. So like that, multiple interactive exercises are available here. There are exercises available for like understanding the circuits of hydraulic conveyor, the circuits with function in parallel. Then there are also circuits to learn how to troubleshoot. For example, if I see here, if we extend this button, so you can see here like the flow chart is given here. So on the right side there will be a circuit where different failure scenarios will be there, and based on the behavior of the circuit, like here different buttons are there to activate a particular type of failure in the circuit, and based on the selected tab there will be different scenarios, and using this flow chart a person can analyze what is a problem in the circuit, and they can learn how to troubleshoot different types of components. So there are multiple types of exercises available here for the hydraulics. Similarly, there are exercises available for electrotechnical, pneumatic, as well as automation. So we will see those in details in our next webinar sessions. So these were about some of the training materials available here. Then now very quickly, we will see some of the demo files. So from the demo tab, I'll load the demo. Okay, so here I have made some marked labels. So for example, we will see alt technology, Allen Bradley PLC. In this, we have for the automation, we have used Allen Bradley PLC. So let me just open this. I'll adjust. As mentioned before, like Automation Studio is a multi-technology solution. It can be used in collaboration. So here you can see this is an hydraulic circuit, this is a pneumatic circuit, and this is a PLC ladder logic which will automate this, and this is the HMI control panel. And this is the virtual design, like how this will be do the drilling. Okay, so here from the control panel, if I start the, you can see the motor 1 is now running, so that's why this is in green. So now this is automated using this PLC ladder logic. You can see as per the logic, my cylinder is getting extended or retracted, right? In between, let's say if I want to do the emergency stop button, so I'll press this. Now my motor has stopped and this will stop working. Now again, if I release, it will again start working. So like that, you can create different types of exercises using multiple technologies in Automation Studio, and you can learn how to automate your hydraulic or pneumatic circuits. Similarly, there is another example of pick and place. So let me just adjust the pages. Okay, so here this is a hydraulic pneumatic circuit. This is a electrotechnical AC/DC motor control. So through this DC motor, we are controlling the motor of our hydraulic circuit. And this is like a 2D view, the virtual system that we have created for the pick and place system in Automation Studio itself. So if we start the simulation and if I start the main, so this green indicator is showing like the system is running and my pick and place is getting run automatically. And the similar operation you can see here in your hydraulic circuit, hydraulic and pneumatic circuit here. Okay, if you want to see like what is the effect of this motor, you can in between you can just disengage this motor and the circuit will stop running. And as you can see here this emergency stop, if I'll click, this red indicator will start, and it will uh, make the user know that there is some problem in the system, and he can come and he can stop the system. So you can see this is blinking. My sequence, the pick and place system is still working, but it's just giving the indicator that there is some problem. So like that, different scenarios can be created. In the previous example, using the emergency stop, you stop the system. Here we are just giving the warning signal. So like that, different scenarios can be created for different types of automation. So we have covered by this all the topics that were included in today's webinar. If you have any questions, please do let me know. Sachin, if there are any questions, then please let me know so that I can explain.
Pooja, there are no questions right now.
Okay. We do have still time, so if anybody has any questions, then please post it here or raise your hand. We can answer it now. So if you have any question, please raise your hand or post it in the question section. Okay. I think we don't have, I think we have just, can we record a video in this Automation Studio application? Yes, you can record a video in the Automation Studio applications. Here in the tools, you have two tabs, asynchronous recording and synchronous recording. So this synchronous recording will do the recording once the simulation starts. But if you want to record from the addition, like when you're creating a circuit and post the simulations, then you can use this asynchronous recording. Here in the recording options, you have option like if you want to capture the application area or the work area, if you want to show the mouse click or the mouse movement, if you want to have like your audio to be recorded, so you can activate the audio recording. You can choose a recording device. Like that, you can set your requirement, and you can, while recording, you can also pause the recording and you can again start the recording. For example, if I start this and if I click on this asynchronous recording, and if I stop the recording, you can see here I have got like play video, or if you want to save it, so you can save it as your desired location, and you can give the name in the MP4. Okay.
There is a one request. Can you please brief again a little for hydraulic schematic? I joined little late.
Hydraulic schematic like this, or the illustrate this one?
Yeah.
Okay. Okay, so I'll just recreate this hydraulic circuit. I'll delete this all. Okay, so in hydraulics, if you click on the hydraulic library, on the first click, the default window, you will have the most commonly used components visible here. And if you click on a component, you can select the standard in which you want to create your circuit, whether ISO 1991 or 2012. Once selected, then you just need to simply drag and drop your desired component onto the editor area. So for this, I will need a pump, a basic hydraulic circuit, a pump, actuator. And then I will need a directional valve to control the direction of the cylinder. Then a relief valve to control the system relief valve, and a engine I would need to connect with the shaft of the pump, so that I can take from the drives and transmission elements. I'll take an engine and I'll just bring it close to the port of the shaft, and the connection has been made. Once you can see the black square. Now all the hydraulic lines, the cursors will be round, the ports will be round. Now you can just make the connections, P to P, and the A and B port of the cylinder to the A and B port of the directional valve. Or the relief valve, you can simply input of the relief valve to the output of the pump. And then the tank, you can either take a copy of this, you can take again from the library, or you can again connect it back to the same tank. Similarly, let me take another copy here of the tanks just to show this. So like that, in no time, you can create a hydraulic circuit here. Can you monitor the hydraulic oil temperature during working? Yes. For that, from the simulation options, you just need to go here and you need to activate thermal evolution. Okay. And then in the edit, hydraulic, you can define what will be the initial ambient temperature, what will be the initial fluid temperature. You can select the fluid type that you want to use. Based on that, the viscosity and the density, everything will be selected. And then if you start the simulations, and if you want to measure temperature at different ports, you can have the node. You can select the temperature here. Okay. So as you can see here, the temperature is getting increased because everything is getting lost. So
One
now the
question.
temperature.
Each Automation Studio Education E7 has free demo for 1 month as yet, or it has to be purchased or to use it?
I think Akshay can answer on that. Akshay, please.
I guess Pooja have already answered that question.
Okay.
Yes.
On addition to this, the measuring instrument on the thermal evolution, I also want to show you, like in the hydraulic library itself, we have this fluid conditioning library where you have different types of coolers, heat exchanger, fluid coolers, which will be used in your thermal evaluation. Okay. Any other, I think, how can we access technical training material section? So this should be there by default. I think it comes as an add-ons. It will be there with your license by default. So you just need to add it in your, if you don't have it now, then please let us know. Our team will help you to do the installation. It will be free with your license, complimentary package.
How the values are changing in simulation? Which kind of formulas were an equation used to calculate that?
Okay, so each of these components have been like, if you see here, for example, if I go to this pump, sorry, just a cylinder, if we take an example of the cylinder, so you can see here, whenever you will open a component in the component image section, you can see like what are the parameters. um, like for example, the flow, it is function of your AP, IL and mu c. What is IL? Is an internal link. What is mu c? Viscosity compensation. So how this flow and everything is going, how the force is acting, on which these are dependent, what are the formulas, everything, like what is the effect of inclination, gravity, everything is shown here. So these formulas have been used while during the simulation if you run.
Can you please give information on failure analysis and fluid section available? I guess that is for
Okay,
advanced
this
hydraulics.
is I think they are talking about FMECA.
Failure analysis and fluid section available. That fluid section
This
and
is,
that yeah, yeah. I
yeah,
guess that is in advanced hydraulics. I guess.
yeah. So FMECA is a like another tool for which there could be another session. And apart from that, the modelings and other things that will be covered in the third webinar session that we have mentioned, like how you can do the modeling and everything, how the like different fluids can be managed. And also here I mention you, like from here, fluid and line manager, you can click and you can select the oil which you want to be used in your project, and here you can set the different properties of that. You can create your own fluid also, and you can define the values accordingly.
And there is one another question. If we have hydraulic circuit diagram PDF, can software prepare a model and simulate it automatically?
No, you have to, if you have the circuit design with you, you need to create that circuit in Automation Studio yourself, because as you can see, as we have told you, this is just not the CAD. These components come with a behavior. So that behavior will not come automatically if you export the design in the Automation Studio. For to get the behavior and the simulation, you need to create the components from Automation Studio library or from the components available in the catalogs.
how we can access technical training material section.
Technical training material and demo tab should come automatically on your ribbon bar if it is installed with your package. So this is a complimentary package. It should be there. Correct installation should be done, and it should be here, this demo tab and technical training material. And if you click on any of this tab, the CTGX, the catalog for that will be open in your catalog manager.
So there are no questions further.
Can we have access to webinar video? You will get the webinar video links post this webinar. Okay, thank you. So if there is no more questions, so we can end today's webinar section.
Yeah, Pooja madam. So I'll share the
Yes.
screen now.
Yeah.
Yeah, hope my screen is visible.
Yeah.
Yeah. So finally, we are at the end of today's webinar. Hope everyone is good with the session. So for any queries related to the products, you can send us through the inquiry didactics@genetics.co.in. And also you can visit our LinkedIn page at genetics. So we have the series of webinar planned on upcoming days. The next webinar is on 18th May. The topic is advanced hydraulics. For every session, we have a separate registration link. We request you all and your peers to register and bring it to play. Thank you. Thank you. Thank you, Pooja madam.
Thank you, Venkat. Thank you.